Okay, so here is what I thought that it would be useful from such a circuit. Number one, only two knobs for tuning instead of three or four that other products use. Um, that's really the most important thing as far as concern the user interface. If you have less knobs to tune, that's much better in practice. You can tune the thing much easier. Combined with number 2 and number 3 below, which is a small interaction between knobs. You basically don't want a very large interaction when you tune the phase or when you tune the amplitude. You don't want the first to interact with the second too much, or vice versa. And the controls have to be non-touchy. We have to have enough span, let's say, enough span for the amplitude and the phase, and the components used to actually do the tuning must be knobs without sticking points or grease into them and backlash. We have to really tune the thing as easy as we can, and we have to ensure that we must not go back and forth in the tuning potentiometer to do the tuning. It should be set right at the point that we leave it, and it should start right at the point that we touch the potentiometer, as long as we touch it. The other very important thing as far as concerned the noise cancellation is the circuit has to be broadband, at least 0 to 360 degrees of phase shift, and at all frequencies between 1.6 to 30 megahertz. And I'm using 1.6 as the lower point because I would like to the circuit to be used also by on 180 meters, 170, 180 meters band. So this is not a ham band, but I would like the circuit to start to be useful from there, because lots of people there experience quite a lot of noise in this band. So the other thing is lots of amplitude range. That is very good attenuation, very high attenuation when it's needed, and very high amplification when it's needed. So the circuit must be able to cope with different noise antennas. Either they are sensitive or insensitive. It has to have the appropriate gain range to cope with the different types of noise antennas. And it has also to have a large noise handling capability. The circuit should not overload too easily by large signals, which will make the circuit unusable. And another thing very interesting that the products of the commercial products do not achieve is absolutely zero compromise in the dynamic range of the signals. How is that possible? Well, it is possible, and I have already tested those things. And what we actually need here is with this point, the number 7, is to not compromise any signal, any useful signal that is coming into our receiver. So the final thing is some different options that I'm thinking for that noise antenna, and these two last points will be implemented in the final product, the NR-2. So yeah, that's basically the things that I would like the circuit to have. So based on those things, I have done many simulations those latest months, many simulations, lots of hours of working, testing, and discarding ideas and trying new things, etc. So I think I have made a very nice circuit that behaves very nicely, and it's not very difficult to build. It has lots of components, but it's not difficult to build, and certainly not that difficult to be built in large quantities. So the circuit behaves quite okay. I'm very happy with it, and it achieves the things from this list. And I think I'm going to show you now the experiment, the actual experiment of the circuit, because not only I have simulated that, but I have also built the actual circuit, which is of course what this is all about. And I'm going to show you now the experiment that I have done. I'm going to use the oscilloscope and the signal generator and test this circuit that I have built in different frequencies to see how well it behaves.